All right, so I want to kind of summarize what we've done so far. So far, we have learned to calculate limits by substituting into the function. Now, this only works for functions that are continuous near the x value we are approaching. It doesn't have to be continuous everywhere, but it has to be continuous at that x value that we're plugging in. The other thing we've done is we've looked at a graph and we've found the limit. And the last thing we've done is we've looked at a table and we found the limit. But here's the problem. The problem is sometimes we won't have an easy function to substitute into, or we won't be given a graph, or we won't have a graphing calculator to find the table. And plus the table takes a lot of time to do. So we have a lot of ways that we can get around this, and our solutions are going to be topics that we're going to cover. So we're going to be finding limits by factoring and canceling. That's this topic right here. We're going to be rationalizing the denominator and the numerator. And we're going to simplify compound fractions. And we're going to also tackle limits involving trig functions. Now, let's review 1, 2, and 3, just so you feel comfortable knowing what we've learned so far. So here's an example of a problem that we can substitute into. Now notice that it is continuous at 2, meaning I can plug 2 in and there's no issues, like there's no issue with the denominator being 0. So this is going to be 3 times 2 squared minus 2 times 2 plus 4. Well, order of operations, I do 2 squared first, so that's going to be 3 times 4 minus, well, 2 times 2 is going to be 4 plus 4. So this gives me 12 minus 4 plus 4. Okay, well, we go from left to right once we're left with addition and subtraction. So it's going to give me 8 plus 4, because I do this first is 8, then plus 4 is 12. So this limit is equal to 12. All right, so that's how we substitute into a function. We can only do it if we're able to plug in that number without getting a 0 in the denominator or any other issue of plugging that number in. All right, the other way that we've learned to calculate limits is by looking at a graph. So what we do here is we make sure that the one-sided limits are equal. So for example, the limit as x approaches 0, we'll call this graph f of x. Okay, the limit as we approach 0, well, the limit from the left is 2. The limit from the right is 2. So our limit as x approaches 0 is going to be 2. We've also learned that sometimes the limit doesn't exist here. So for example, the limit as x approaches -1 of f of x. Well, here I'm approaching -1 from the left. Our limit is 0. From the right, I'm approaching -1. My limit is 3, which means the limit does not exist when it's approaching just the two-sided limit of -1. So we've done that. And the last thing we've done is we've calculated limits using a calculator and that graphing calculator to help us make a table. So if I ask you what's the limit as x approaches 0 of 20 sine x over 4x, well, what is that going to be equal to? It looks like 4.9999, 4.9999. The left-sided limit, which is us coming from the left, gives us 5. The right-sided limit is going to give us 5 from that direction, and so we're approaching 5. And notice how we cannot plug 0 in. So we could not have done this problem by direct substitution because it's not continuous at that x value right there. But we certainly could use a table, or we could graph it and see what it approaches. Okay, so again, we have covered these 3 topics, but sometimes we won't be able to do it that method, so we have some solutions. And the first one we're going to tackle is factoring and canceling. So let's go ahead and get started on that. All right. The limit as x approaches -2 of this function. Definitely get this down. And maybe pause the video and see if you can factor this on your own. All right, I know it's tempting to just rewrite this without the limit, but technically we do want to rewrite the limit as x approaches -2, and then we want to factor. Okay, well, let's factor this by pulling out a 2. So that gives me 2 times parentheses x plus 2 divided by, okay, now we have to factor this. And this is just a 1 out in front, so this is the easy way to factor. We're trying to add to this number and multiply to this. So what two numbers add to -3 but multiply to -10? Well, that's going to be a 5, a -5, and a 2. Okay, let's check that. Those multiply? Yep. So those add? Yep. So we're going to have an x, and then you're just going to copy this down. I'm going to have a -5, and then I'm going to have an x plus 2. Now, does anyone see something cool here? If you said that yes, something cancels, you're absolutely correct. So you're going to cancel out the x plus 2 with the x plus 2. And now I'm going to rewrite this as the limit as x approaches -2 of just plain old 2 is left in my numerator, and then x minus 5. Okay, now I'm going to plug in -2 because there's no issue now. It's almost like, okay, now I can plug this in now that I don't have an issue with plugging in -2 in the denominator. If I had done that originally, I would have gotten 0, right? So that's an issue. So I'm going to plug in -2 now, and I'm going to get 2 over -2 minus 5. And notice how as soon as I plug into my limit, I can drop that limit symbol. All right, and now this is going to be 2 over -7, and that's our answer. Again, I'm going to emphasize that if we plugged in -2 to begin with into my x's, I would have gotten 0 in the denominator, which means direct substitution would not have worked. All right, this next one is a little bit scary, right? Because I'm going to have you do sum of cubes. And if I ask you to do this, I will absolutely give you that formula. You don't have to have that memorized, although you did in pre-calc. So what's the limit as x approaches -3 of this function? Well, let's go ahead and let's factor the numerator, because I already said to myself, hey, I can't plug in -3. That's going to give me a 0 in the denominator. So that's a problem we're going to need to factor. So if I have x cubed plus 27, I can rewrite that as x cubed plus 3 cubed, meaning that this is a equals x, right? A cubed would be x cubed, so my a is x, and my b is 3. So my b is equal to 3. Why is that true? Well, because 3 cubed gives me the 27 that I have here. So now I'm going to go ahead and plug that in, and I'm going to rewrite this as the limit as x approaches -3. And I'm going to have my a plus b, so this is going to be x plus 3, right? Because my a was x, my b was 3. And then I'm going to have a squared, well, that's going to be x squared, minus my a, which is x, and my b, which is 3. So I'm just going to write that as x3, or instead, how about 3x? Plus b squared. Well, what's b squared? What's 3 squared? It's 9. So my numerator becomes x plus 3, and then I've got x squared minus 3x plus 9. And then in the denominator, I have x plus 3. Okay, hopefully you see something good here. You can see that my x plus 3's cancel. And now I'm going to go ahead and say, oh, now I can plug in the -3. Now I'm not going to have a 0 in the denominator. So everywhere I see an x, remember, keep your parentheses when you're substituting in. So that'd be -3 quantity squared minus 3 parentheses -3 plus 9. And then there's nothing in the denominator, so if you want to put it over 1, you can, but there's no need to. Again, I'm going to emphasize the fact that as soon as I plug in, I can drop that limit. So this becomes 9. Okay, that's from -3 squared, and then it's going to be plus 9 all over 1, and that's going to give me 27. Awesome job. All right, here are our last three problems, limits by factoring. Now, I do want to remind you how you do this one. Boy, it's been a long time, and I feel like we covered it in Algebra 2, we covered it in Pre-Calc, and now we're seeing it again here. So this is that one where you multiply these two values. Okay, so let me redo this. So 2 times -5, that's going to give us a multiply to -10. And then you're going to add. You're trying to add to this. All right, so I'm trying to add to 3. So we've done this one already, but I think the signs are going to be different. But this would just be a 5 and a 3, and we would have to have, excuse me, a 5 and a 2. We'd have to have the 2 be a negative this time, because 5 times -2 gives me this. 5 plus -2 gives me this. So this is a little bit of a side, right? This is not the actual problem, so let's just say this is the side. So I'm going to rewrite this as 2x squared, and then I'm going to write this one minus 2x, and then I'm going to write this one plus 5x, and then I'm going to have minus 5. Underline, underline. This should be review. We've done this a lot. I'm going to pull out a 2x, and we're going to have x minus 1, which means I immediately over here go x minus 1. And that's going to be a 5 on the outside. So I'm going to have a 2x plus 5 times an x minus 1. And I kind of notice now that I used x instead of t, but that's no big deal. I'm going to rewrite this now as the limit as t approaches 1. My numerator is going to be 2t plus 5 over t minus 1. All over 1 minus t. Okay. Now, we've got a little bit of a problem here, and that problem is things are not going to cancel. But I've got an idea. What if I multiply by -1 over -1? Well, what is -1 over -1? It's just simply 1. So if I multiply this by a -1 and I multiply this by a -1, let's rewrite that now. That's going to give me, and I'm just going to keep my -1 on the outside on the numerator, so -1 times 2t plus 5 times t minus 1. But in the denominator, I'm actually going to multiply this through, and that's going to give me a -1 times 1 is -1, -1 times -t is a plus t. And now we actually have a match. And I'm going to rewrite this as, instead of -1 plus t, sorry, that's a little hard to read. Instead of writing -1 plus t, I'm just going to switch those, and it's going to be t minus 1. I've not changed anything, it's just rewriting it. So that's going to be a t minus 1. So you can see by multiplying by -1 over -1, it put a -1 there, but then it made our denominator such that I can now cancel. All right, next thing I'm going to do here is take this 1, and I'm going to plug it in. And so that's going to give me -1 times 2 times 1 plus 5. Okay, we need to do parentheses first. So that's going to be 2 plus 5 is 7. Times -1 is a -7 is our answer. All right. It's really important that you kind of keep going with me, because I am showing problems that are different from each other. It's not like there's the same problem over and over again. All right, let me erase this to give you some space, or myself some space. Okay. Letter D here. In this particular one, we can see that we can't plug in 0, but also I don't see anything to factor. So this is actually going to be one where I'm going to FOIL this out, and then I'm going to be able to cancel after factoring. So let's go ahead and let's FOIL that out. That's -1 plus h times -1 plus h. First, outer, inner, last. Okay, this is review. If you do the box method, that's great. You can kind of do this one. Would be -1 plus h, -1 plus h, and you get your box. I'm going to do FOIL. I think it's faster. First times first gives me 1. Negative 1 times h gives me a negative h. Inner gives me a negative h. And last gives me an h squared. All right. So that's going to give me a 1 minus 2h plus h squared. Okay, keeping that there as a reminder. I'm just going to rewrite what I have here. I've already FOILed that out, so now I have the limit as h approaches 0. That becomes 1 minus 2h plus h, and then minus 1. That minus 1 is coming from right here, all over h. All right, so now that I have that written down, I think I forgot my squared here, didn't I? Because it was h squared. Okay, now you can see that the 1 and the minus 1 cancel. So now we're left with just a negative 2h plus h squared. Well, I can actually pull an h out. This is now when I'm factoring. So I'm going to have a h, and I'll have negative 2 plus h there. If you want to just check that, h times negative 2 is a negative 2h. H times h is an h squared. Okay, so now I still have divided by h. So my h's cancel. And now I can actually go ahead and plug 0 in for h. And that just gives me negative 2 plus 0, gives me a limit of negative 2. All I did was take that 0 and plug in. All right, last one here, folks. I know this is a lot, but we can do it. Okay. Here, we can rewrite 27 as 3 cubed. So I am in the form of a cubed minus b cubed. So my a is equal to 3 plus h, because 3 plus h is being cubed. And then my b is equal to 3. Okay, so let's factor the numerator. And don't forget, I know you're going to be sloppy about this. I've seen it my whole life. Make sure you rewrite the h approaches 0 with the limit. So now I'm going to write a minus b. So that's going to be, a is going to be 3 plus h, and then minus b is going to be minus 3. And then I'm going to have a squared, which is 3 plus h squared. And then plus ab is going to be plus, I guess I'm going to write the b first, 3, and then 3 plus h. So this is AB. All right, and then what do I have? Plus B squared. So that's going to be plus B squared. So that's just going to be plus 3 squared, or plus 9. All over H. All right, well, what happens with a 3 and a minus 3? Well, they cancel. So I'm really just left with, up here, I'm just left with H. And hopefully you noticed that before. These cancel, and now all I have to do is plug in 0. For every time I see an H, I'm plugging in 0. So I have 1 in the denominator, and this is going to be 3 plus 0 squared is going to give me 9. And then 3 times 3 plus 0 is going to be 3 times 3 is another 9. And then I've got that plus 9. So I've got 27 again. All right, thanks for watching, folks. Just remember, the summary of this is if you can't plug in your value from the start, you have to factor, then you cancel everything that cancels, and then after canceling, you can go ahead and plug in. Awesome, have a great day.